We're going to talk about different types of graphs. So it says, use the summary graphs from a personal fitness tracker to answer the questions that follow. And it says round each percent to the nearest whole percent. Okay. So I think that what we'll do is we're just going to use this, my notes here just for the first page, and then we'll go back to the handwritten notes. So it looks like we have someone burning calories throughout a day. And it looks like everything that's like the light blue color is the sedentary, I believe is how you say it. And that basically means that they're not very active. And then there's lightly active, fairly active, and very active, okay? So the first question it says is, during what percent of a person's waking hours is he very active? So if I was to try to find out a percent that they're very active, which graph would I use? Would I want to use this first one or the one that looks like a circle?
My vote's for the circle.
Okay, yeah, and why would you use the circle?
Because the circle represents the whole 24 hours.
Well, if I look at the circle, it doesn't necessarily represent 24 hours, right? Because if I add these together, I have like 10 hours, 3 hours.
Sorry.
It's more than that though, right? Because we have like 10 plus 3 plus 1 hour. That's 14 hours right there. And maybe another hour in between those. So we have about 15 hours here. So if we look at it, it says that we have a breakdown excluding sleep, right? So it is those 24 hours, but we're subtracting out the amount of time that this person slept for. So it's only like 15 or 14 hours, right? But yes, I do agree that we should use this chart, or this, we call it a pie graph or a circle graph. Okay. So to find out that percent, what can we do here? So what do we have to add together, and what are we going to divide by, and everything else? Because this is just finding what percent of the pie this very active is, right? So what I'm going to do is just like our part divided by whole formula, right? So I'm going to have 22 minutes, and I'm going to divide that by, and I'm going to divide that by adding all the rest of these up. So I'm going to add the fairly active up, the very active, the lightly active, and the sedentary. So I'm going to add all those up, and I'm going to divide that by 22 minutes, right? So I'm just dividing the part, so this little sliver, divided by the whole thing. Okay. So one thing we'll have to do is change the hours into minutes, right? Because we have minutes here, so we're going to have to divide by minutes to get an accurate count. So I'm going to do that really quick. I'm going to add all those up. So if I do that, I'm getting 918 minutes. So 22 divided by 918 minutes. We should get about 2.4%. So after you round and change it into a percentage. Okay. Now, that's not very much, right? 2.4% is pretty small. And that's accurately reflected on the graph, right? Like this is a little sliver compared to the whole thing. So 2.4% makes sense. Okay. So I kind of already spoiled the next question. So the next one says, what percent of the day does he sleep? Well, we know that all four of these, 1, 2, 3, 4, is his activity excluding sleep, right? So we know that there's 24 hours in a day. And we can just subtract that by the number of hours that he's awake, right? So if we just add those all together, and maybe we just keep it in minutes, right? Since we already have how many minutes are on this pie, we have 918 minutes. So we're going to subtract 24 hours from 918 minutes, right? So I'm going to have to change this a little bit. And I can change that by changing these 24 hours into minutes, right? So we can change 24 hours into minutes. So that's just 24 hours times 60 minutes in an hour. We get 1,440 minutes in a day. And we're still subtracting the 918 minutes that he's awake for, right? So if I do that, we get that he sleeps for 522 minutes, which is also equal to, so I'm going to divide that by 60 minutes, 8.7 hours. Okay? So I'm just dividing this by 60 minutes in an hour. Okay, so we have those first two answered, right? So which graph, should I use the pie graph again or this bar graph up here? During which periods of the day does most of his light activity occur? So which one is going to be better to show me what time is his light activity will occur at?
The circle graph?
Sure, so if I use the circle graph, can this tell me if he's lightly active at, let's say, 6 o'clock?
No.
Sure, okay. So we know that the circle graph probably isn't the best thing to do, right? Because this just averages all the times up. So if we look at this bar graph up here, we see that he's lightly active in this part, everything that's green, right? So it looks like he's lightly active maybe from 6 in the morning to maybe 8. So 6 a.m. to 8 a.m., right? And then I also see that he's lightly active in the evening, maybe from 4 to, I don't know, maybe 10 p.m. So from 4 p.m. to 10 p.m., right? So this bar graph maybe doesn't necessarily compare them like the pie graph does, but it gives us more information, right? It gives us information at certain times of the day. Okay. Does anybody have any questions on that one? And I guess I kind of skipped ahead and answered the last question as well. So the last question says, what information does each graph that the other does not? So I would say that this bar graph is better at specific times. So the bar graph gives specific times, whereas the pie graph shows averages, or I guess it compares parts to the whole. So basically it just compares parts of certain times to the whole percentage of time, 100% of the time that he's awake. And I guess that's another advantage of the bar graph as well, where it shows the time that he sleeps, maybe from 10 p.m. all the way up to, about 6, right? So it shows the time that he sleeps as well, whereas the pie graph does not. Okay. All right. Does anyone have any questions on that page? Okay. All right, so I've answered that page, so let's go on to the next then. So we're going to create a pie graph now. And the reason we're going to create a pie graph, personally, I really like pie graphs just because they're an easier way to visually show information. I'm definitely a very visual person, so that's why I like graphing and stuff as well. But what we're going to do is we kind of talked about percentages on the last page, right? So we know that percentages are going to be pretty important for pie graphs. And the reason being is showing percentages shows you how much part of that pie that you need to fill in, right? So I'm just going to go through an example to show how to create a pie graph here, right? So the first thing I'm always going to do is I'm going to have a center point. So I'm just going to kind of guess where the center is. Okay? And the second thing I'm going to do is I'm gonna read read the problem, right? So that's probably the first thing we should do. My bad. So it says Ian attends a company-sponsored workshop that is designed to increase employee efficiency. His task is to create a pie graph showing how he uses 8 hours at work on an average day to help him analyze how he can better use his time. So it says represent the information in a table with a pie graph. So we're given this table, right? And we're given how many hours he works in each category. And we know that his total amount of hours worked is 8 hours, right? Because that's his work day. Okay. So what I'm going to do is I'm going to divide every one of these by 8 to find out what percent of the time he spends on each category. Okay. So I'm going to do 1.5 divided by 8. Just write a division sign, and I'll just do that for the first one. So we're just going to divide that by 8 and change it into a percentage. So 1.5 divided by 8, we get about 18.75%. Okay. Then I also see that number pops up at the bottom for off task. So I'm going to have the same percentage for that one. Oops. Okay. And then I'm going to do 2.5 divided by 8. So I get 31.25%. I'm going to do 1 divided by 8. So we get 12.5%. 0.5 divided by 8. Get 6.25%. And then we get 1 divided by 8 again, which is 12%. Or 12.5%. Right? And if we add all these up, I'm going to get 100%, which is just the whole graph. Okay? So now to graph these, I'm not necessarily worried about the steps that they give up here. I want you to get kind of a sense of the size of each of these. Okay. So the first thing I'm going to do is I'm just going to draw a line from the center, and I'm just going to draw that straight up into the graph. Okay. And the reason I'm doing that is because I'm just going to start filling in pieces and go all the way around. So we have a few choices. We can go down the list. We can start with the biggest and then go to the next biggest, all the way to the smallest. We can start with the smallest and go bigger and bigger and bigger. So like the opposite of the second one. And they'd all be correct. So I think what I'm going to do, I'm going to start with the biggest one, and then I'm going to go smaller. And I think that just might be the easiest way for me at least. Okay. So if I look at 31.25, if I think about that as far as easier fractions to work with, I think that's almost a third of the graph, right? Because about 33% is going to be a third of 100%. So I'm going to draw a line here, and I'm just going to kind of guess. Maybe right about there. So that's about a third of the graph. Okay? And I'm going to label that C for computers. And then I'm also going to write in the percentage as well. Okay. And then I can do that with the rest of them, right? So the next one's going to be meetings, which is about 20% or about a fifth of the graph. So that's meetings. And it's going to be about 18.75%. And then I can draw the exact same thing for off task. So I'm going to stay on that center point and draw about the same size here. So that's going to be for off task, or just I'm going to label it O. Write the percentage in again. Then I have calls and lunch are both 12.5%. So maybe something kind of like that. It's just as a guess. So I'm going to write the first one for lunch. That's 12.5%. And then I already have C for computers. So I'm going to label the next one CA for calls. That's 12.5%. And then finally, I have breaks, right? So I noticed that on my graph, I messed it up a little bit, right? Because they're not necessarily accurate sizes. So I'm just going to label the last one breaks, and I'm going to label it 6.25%. And this is a good example of why we have like Excel and other things to make graphs for us, because we're pretty bad at making it, right? Just as people. So that's why I always write the percentages in there. So if you ever do have to make a pie graph, like maybe on the homework or whatever, that's why you always put the percentages in. So if you do mess up something like that, you don't have to redo the whole thing. So I can still tell that you did this right, but maybe just the slices are maybe a little bit off. Okay. Okay. Does anybody have any questions on that one?
So you're saying on homework, we will be graded on correct percentages, not
Right. And
correct.
I want to say, yeah, I want to say on the homework, it might actually just make it for you, and it's just looking for you to fill in the information as far as the percentages, and then it'll automatically fill that in for you.
Okay, thank you.
Yeah. Any other questions? Okay. All right, we'll move on then. So on the next page, we're going to talk about bar graphs. So bar graphs are like the very first graph that we saw at the start of this section. It's going to be something like this. And a specific type of bar graph we call a Pareto chart. And all that is just ordering it from tallest to shortest. So the biggest numbers to the smallest numbers, okay? So the first task we have here for a bar graph, so this one says create a Pareto chart, which is just a special type of bar graph, to display the top 10 average gas prices by state in the US. So we're given this graph in alphabetic order. And just to make this easier so you don't have to do this all yourself, but I think we will make one later, maybe. No, I don't think we make a bar graph later, but that's okay. So we're given this in alphabetic order. And what they did was they just ordered this from highest price to lowest price for average gas. Okay? So what they did, and I'll just show you an example, they created a chart, right? So they have an X and a Y axis. They labeled all the states down here, and they put prices here in equal increments, right? So what they did is they saw that California was the highest average gas price. So they looked at, it looks like it's $3.60 for gas here for your average. So all they did was put California, and they drew a bar all the way up to that $3.60 price, and then drew a bar all the way back down, right? And then they just filled that in. And then they did the same thing with Alaska, since that's the next highest one. It was $3.42. So they just drew a bar for Alaska all the way up to $3.42, drew it back down, and then filled it in. Okay. And you can do that with all of them, right? So they just ordered it from highest to lowest and just filled in the bars. Okay. Does anybody have any questions on how they made that bar graph? Okay. All right, we'll go to the next page then. So the next page, it says, here's how it works to create a vertical bar graph. So what we're going to do is we determine the categories that will be graphed and the values that will be graphed for each category. So in the example they give is similar to that rating that we did in the last section, where we had certain ratings and we have how many people, or the frequency. So how many people rated this app 5 stars or 4 stars or 3 stars and so on. Okay. So we know that our ratings, we're going to want those on the x-axis because that's what the ratings are. And then the frequency, we put it on the y-axis since that's how many of those ratings there are, right? Okay. The second step is draw and label the axes. So we just labeled it 0 to 10 here for the frequency. And then we rated it 1 to 5 for the ratings. So we just labeled the axes and then put in increments. Okay. And I guess that's kind of step 3 as well. It says use the values to draw and label the tick marks on the vertical axis using a consistent increment. So basically that just means your consistent increment They went in increments of 1. You can go increments of 1/2 and so on. But they have to be the same for each tick. And then finally, we just draw the vertical bar graphs. So they can either be touching or evenly spaced on the horizontal axis. So on the last page, we saw that they were apart. But in this one, they decided to put them together. So they're all touching, right? And either one is correct for a bar graph. Right, we can do it either way. But sometimes they're a little bit better if they're apart or together, just depending on what you're doing. So like in the ratings, I think it's kind of nice that they're together because they're bigger. Maybe they're easier to read. Maybe some older people, if they have like trouble seeing, sometimes the bigger bars are easier for them to read. Okay. All right, so we've done the bar graph, we've done the pie graph. So now we go on to the line graph. So that's our third type of graph for this section. So a line graph, it's just a series of connected ordered pair data points. It says since quantitative data has an applied order, we can connect the dots. So what a line graph is doing is it's just showing a change over time. Okay. So a line graph is just showing a change over time. Okay. And I think, yeah, on the next page, we actually have an example of a line graph. Okay. So this one says, the data that accompanies over-the-counter prescription drugs is full of important, often mathematical information. So it says in the graph, the vertical axis represents the concentration of acetaminophen in the body, measured in micrograms per milliliter of blood. So you can pretty clearly see one of the graphs, maybe not necessarily so for the other one. So I'm just going to kind of draw that in here. Something like that. That's the second graph. Okay. And the first question says, write the ordered pair for the point indicated by the arrow and interpret it. So we have a point right here. And that point, it looks like it's at 212, right? So we look at the x-axis first, and then we look at the y-axis. So it's on 2,12. Okay. And what does that mean? Well, it looks like 2 hours in, there is 12 micrograms per milliliter of acetaminophen in this person's bloodstream, right? So after 2 hours, there is 12, and I'm just going to label it how they did. So it's micrograms per milliliter of acetaminophen. So I'm just going to label it of A in the person's body. Okay. Okay. So we labeled that point. We know what that exact point looks like. Now let's examine the graph as a whole. So question B says, use the shape of the graph to describe what happens to the concentration of medicine in the body over 8 hours and how or why a second dose is needed after 6 to 8 hours. Okay. So we look at both the graphs. We can kind of see them spike, and then they kind of slowly come down, right? So that's what happens over 8 hours, right? So it spikes up to a maximum, and then it just kind of slowly falls off. So that's the first part of my question, right? So the graph spikes, then slowly falls over time. Okay. And then does anybody know why would we need a second dose after 4 to 6 hours? So why would we need a second dose of acetaminophen after 4 to 6 hours?
Because it gets down to the lowest point.
Right. So does anybody know what acetaminophen is or what it's used for?
It's just ibuprofen or
Yeah.
Tylenol.
Yeah. Just,
Acetaminophen is Tylenol.
yeah. That's just the generic name or the medical name for it, right? Yeah. So the reason you need a second dose after 4 to 6 hours is basically because it's almost all out of your bloodstream. It's worn off, right? So I like that. I'm going to say it's worn off after 4 to 6 hours. So if we did take a second dose after 4 to 6 hours, how would the graph change? So let's say at 4 hours, so at this point right here, at 4 hours, we took another dose. So what would happen to this graph? Would it keep going down or would it go back up?
It would spike back up.
Right, it's going to spike back up because you're going to have more in your system, right? And then it's going to start to fall off again, right? Yeah, so Mary has a very good observation. She said, what is the adult liquid versus the tablets at the start supposed to indicate? And why is there such a difference, right? So that is exactly what question C is. So it says, when do the two formula, or wait, maybe it's question D. Yeah, it is question D, sorry. So we'll get to that on the next page. But question C says, when do the two formulations result in the same concentration of acetaminophen in the bloodstream? So just to answer your question a little bit more, Mary, we're going to cover it on the next page. And there's a reason that I didn't address it at the start. So we're going to kind of learn about that. Okay. So if I look at this part C here, it looks like they cross it somewhere right above here. So they cross up here. And then they also cross somewhere down here, right? So that's the two places that they cross, where they're about the same. So I'm going to say that they cross, I'm going to give two ordered pairs. So it looks like at maybe 3/4. So maybe 3/4 of an hour, comma 21. Oops, sorry, it's off screen. So 3/4, comma 21. And that is where they cross right here. And then I'm also going to say that they cross right down here at this point. Okay. So my ordered pair for where they cross right there, we're 6 hours in. And it looks like there may be about 3 for our y-axis. So how much is in their blood? Okay. All right, so does anybody have any questions on A through C here? Okay, so on the next page, we'll get to answer that question here. So let me redraw the line really quick. Okay, so we make a difference between the liquid and the extra strength tablets, right? So why is there a difference? Well, that's going to be our part D, right? So which one would you rather take? So if we were looking at the graph, which one would we rather take and why?
The liquid.
Yeah. So why would you take the liquid over the extra strength tablets?
It enters the bloodstream faster because it doesn't have to dissolve down.
Right. Right. So we see that it spikes a lot higher, right? On this graph, it spikes a lot higher, and then it kind of stays higher than the extra strength tablets for almost the whole cycle, right? So the reason that we have a difference between the liquid and the tablets, we're indicating that because the adult liquid is absorbed into the bloodstream more readily than the extra strength tablets, right? So based on the graph, you would rather take the liquid. Firstly, because it actually goes into the bloodstream faster, right? It peaks a lot faster than the extra strength tablets. So I'm going to say it peaks faster. And then also, so I'm going to put plus, also, there is more of it that gets dissolved into the bloodstream, right? So plus more dissolved into bloodstream. Or I guess I'm just going to put more absorbed. I think that's a faster way to write it. So it peaks faster, and we have more of it that are absorbed into the bloodstream. Okay. Hopefully that answers your question, Mary. So that's why we had a difference, was just to compare them at the end. So, all right. So the next one, E. So this one says the liquid dose is listed as 500 milligrams for 15 milliliters. And then that means that there is 500 milligrams of acetaminophen for every 15 milliliters of liquid. So it says if 15 milliliters is equivalent to 1 tablespoon, how many tablespoons do we need to ingest 1,000 milligrams of the liquid medication? So if anybody had to guess, how many tablespoons would we need to have to ingest 1,000 milligrams of liquid medication? So how many tablespoons? Well, I know that 1 tablespoon is 500 milligrams, right? But I want to take 1,000 milligrams. So what do I have to do to go from 1,000 milligrams, or 500 milligrams to 1,000 milligrams? Yeah, and Sonia said we just need to multiply by 2, right? So if we multiply this by 2, we get that 1,000 milligrams. So we need to take 2 tablespoons. Right, so we're just like doubling the dose. Okay, does anyone have any questions on that? Any questions on this page? Okay. All right. So I don't see any questions, so we'll move on to the next page. So if we ever want to create our own line graph, we need some data, right? The first thing that we're going to do is we're going to determine the variables that we need to graph. So just like a bar graph, we're going to draw and label the axes just like the bar graph. We're going to use consistent values. So in this case, we have 20s for our example for our y's and 5 for our x's. So we're just going to have consistent values again. But this time, we're going to plot the points, and we're going to connect them with a line. So the way that we can do that, if I show like these 3 points here that they plotted, I just connect with a straight line the plot or the one before it to the one next to it. Okay. So it doesn't necessarily need to be a smooth line. You just draw straight lines from the previous point to the next one. Okay. And as far as making the graphs, I'm not super concerned about it. I think on the midterm, it's more comprehending it. So you don't necessarily have to draw it, but you have to know how to read it. Okay. And same thing on the homework. All right, so we're going to kind of summarize what we learned in this section by writing what each graph does. So a pie graph, what it does, it compares parts to the whole. Right, because we're given like a whole pie graph, and then we're maybe given one slice, we compare that to the whole thing. Okay, so it compares parts to the whole. Now a bar graph, it compares parts to parts. So it compares parts to parts. So just draw a few bars, right? So we have maybe this part right here, and we're comparing it to all the other parts, right? So we're not necessarily given the whole picture, but we're kind of given little parts, and we're seeing maybe how big is this one compared to the other ones, right? Okay. And then the last one, a line graph, it shows change over time. So a line graph shows change over time. Okay. All right, does anyone have any questions on this page?